Okay, so let's continue with our coding exercise series. And so open the leetcode.com and go to the problems tab. And in the search question number 199. Hit enter. So we have a question, binary tree right side view. It's come under the medium category. Click on it. So let's read the question. So binary tree. So we have binary tree right side view. So we need to print the right side view. So given the root of a binary tree, so we have the root of it. So in any tree question, generally we have the root is given, because if the root is given, we can scan all the elements of the tree. So the root is given. So if you see the function definition, so root is given. Okay. Imagine yourself standing on the right side. So let's suppose you are standing on the right side of that. Return the values of the nodes that you can see. So if you stand here, what values you can see? You need to return those values, and you need to return in the top to bottom order. So if you stand here, first value you will see 1, the second value you will see 3, the another value you will see 4. So 1, 3, 4. So we need to return in a form of a list. So it means we need some output array, and as soon as we see the value, we are going to append into that. So by looking, and they have only give like along with that, if like if there is no root, so there is no root, then we need to return output like empty array. So this is our boundary condition. All right. Along with that, like I feel like if they give one more diagram, then it will be a good as an example, because if you just look at this diagram, then we might think, okay, we have to print the right side of the tree. Then what we can do? We will not even going to the left side. We will just go to the right side. That is root, or maybe node root dot right. Then once we reach here, then again we go root dot right, and then our question is finished. Once we don't have any more right, then our question is finished. But that is wrong. Why? So if you see the other example, so in this example we are seeing 134. But if you see this example, uh, this example, this example, so we have extended our tree. So if the person is standing here, what nodes that person can see from the right hand side? So 1, fine, 3, fine, 4, fine, but he can also see 6 because there is no blocker. He can also see 7 because there is no blocker. So the output would be 1, 3, 4, 6, and 7. So that's why you can't say like you can't say, okay, the question says right side of the view. So we can't say, okay, we are on the root side, so we are not even going to the left. No, we have to scan each and every element, right? But we need to print the right one, or we can say whatever is visible. Now, how we are going to know whatever is visible? Because if we have to just print right, then what we can do, okay, root is a root dot right. Then when once we reach here, this is the root, then the root dot right. Once we reach here, then there are no more right, so 134. But then this answer will be okay, but in this example, this is going to be fail. Then how we are going to know? Because in this case, we can't say it's the right, but we can say which we are able to see. Doesn't matter whether it's on the left hand side, or doesn't matter whether it's on the right hand side. Okay, so what we can do? So what we have to do is, so the best way or the easy way is, what we can do is we can store all the elements, or we can traverse the tree. Traverse means scan the tree. So we can scan the tree. Sorry. So we can scan the tree in the breadth. So there are two method, BFS and the DFS. So depth first search and the breadth first search to traverse the tree, because we have to traverse the tree. So any one of the algorithm we have to use. So we have to use the breadth first search. So that will be easy. We can use the depth first search as well, but the breadth first search will be easy. Breadth first search means level by level. So first we are on this level, then we are on this level, then we are on this level. Similarly, we are on this level, then this level, then this level, then this level, and then this level. So what we can do is, okay, we will store somewhere. Okay, we currently, so let's take this example. So what we will do, okay, we are on the level 1, so we store 1. Okay, on the second level we have 2, 3. On the third level, we have 5 and 4. On the fifth level, we have 6. On the sixth level, we have 7. Now, whatever the last node of each level. So for the first level, what is the last node? 1. For the second level, what is the last node? 3. For the third level, what is the last node? 4. For the fifth level, what is the last node? 6. For the last level, what is the last node? 7. So it means we have to print the last node 1, 3, 4, 6, 7. Similarly here, if we print level by level, so 1, 1, and then 2, 3, and then 5, 4. So what is the last node of the first level? 1. What is the last node of the second level? 3. What is the last node of second level or third level? 4th. All right. So we have to do that. So we have to do this second. Where is the rubber? Yeah. So let me rub this. So we have to do like a breadth first search because we need all the elements which are at the particular level. All right. So we need to store all the elements. So so in the breadth first search, what we will do? We use the queue. All right. So how to store all the elements? Because okay, first we can store, but how then we have to store the 2 and 3. Then how we are going to know? We will check if there is a left element. Yes, there is a left element. Then we store. Then we store 3. If there is a right element, yes, we have the right element 3. Now we have to store the left of 2 and the left of right, for right of 2, so 5. Similarly for 3 as well, we have to store the right and the left, so it means 4. So we have to scan all the elements but level by level. So to scan the level by level, we have to use the BFS, and in the BFS we have to use the queue. So first we have to use the queue, that is the BFS level, and the initial in the queue we are going to put 1, because in the initial we are going to put 1. So let's jump into the code and let's start writing the code. So let's first take the boundary condition, which is very easy. And one test case will be passed just by putting this logic. So if, yeah, so if not root, so if we don't have the root, we have to just return this list. That's it. So one test case definitely is going to be passed by even doing this. Even you even don't need to write the other code, right? Okay, now the other thing. We need to return list. All right, so we need to store those elements somewhere, so we can take some array resultant array. Okay, now we have to scan level by level. So to scan level by level, we need a queue. So we can take a queue. We can use the dq. Why we are using the dq? Because it's like fast. But anyhow, you can use the queue. Okay, so we are using the queue now. Oh, now, so when we are so initially queue is empty. We already know queue is empty. Okay, fine. Now, in initially, because we are on the root, because we have the root given. So what we can do is in the D queue, we can insert the root element, because if there is no root, we are returning from here. But if there is a root in the queue, we can in this queue, in the starting, in the queue, we can store. Sorry, we can store the first element. Okay, let's store the first element. Root. We have stored the first element. Now, in the BFS, what we have to do is we will run a loop until queue will not going to be empty. So we will run a loop while queue. So we will run a loop until the queue is not empty. So if we come here, so in the queue, currently we have one. Currently we have one. Okay. Now what next? We have to store the left of the queue and the right of the queue. All right. So to store the left of the queue and the right of the queue, first we have to pop this element. What first we have to pop this element, right? So we can pop this element. Okay, so node is equal to q dot pop left, because we have to pop because in the dq it's not the get and the put operation, it's the pop left and pop right. So we have to pop the element. So now in the node we have the one. Now in the node we have the one. So the for the first level we already have the one, and let's take the one resultant array as well. So let's suppose this is our resultant array. Currently this is empty. But we know first level is empty. First level is empty, and we have to store the one here. But if we directly store the one here, like we can store. I can do directly like this. Okay, result dot append node dot value, because the value, because there are three pointers, like one variable going to store the value, one going to store the left, one going to store the right. You can see here in the tree definition. So we can store that. Okay, which is perfectly fine. And at the end we have to return the result array as well. So which is perfectly fine, right? Now till this point is okay. We have one. Now you can say we have popped the element. We already popped the element, and we already store. Now we can check if the node has the left child and if the node has the right child, and then we can store in our queue. We can store in our queue, which is also fine. So what we have to do, if node dot left, so one has the node dot left, so it has the left child, yes. So what we can do is q dot append node. So node dot left, right? And so we have append the, so we already pop one. So now in the queue there is now the queue is empty. So now we are inserting the left element, which is fine. So now we have to check the right elements. If node dot right, q dot append node dot right. So we have appended the right element as well. So right element is 3. So now q doesn't have the 1, or q only have the 2 and 3. But here what we are doing is, so now we inserted. All right. So if we just put this logic, then this is wrong. Why this is wrong? If we just put this logic, what will happen now? So the queue has, for the one it works. For the one we have stored already one. Now for the 2 and 3, we already said 2 and 3, but when it go to the while loop, while queue, is queue empty? No. So let's pop the first element. So it's pop the 2. So if it's pop 2, it is going to store this like a node. It is going to store this node. Node means like 2 into the resultant array. So it is going to store here. But this is not what we want. We want to store the last element of that level. So to check the whether this is the last element or whether this is the first element, how we have to, we if we know the, because what we have to do is we can run the loop, because we can run the loop on it. We can run the loop on it, and as soon as our eye reaches to the length, it means that is the last element. All right, so that is the last element. So what we have to do is, so so run the loop means like for the first element as well, we have to do the same thing. So to run the loop, so how many times, so whether one is the last element or not, how we are going to know whether 3 is the last element or not, whether how we are going to know, because anyhow we have to scan all the element, because now we have to pop 2, because we have to insert his left child and the right child. All right, so let's pause. If we have some element here, maybe 10, some element here, let me put, right. So we have to put all the elements here. Like now if we have to pop 2, so if we have to pop 2, then in the queue it will be 10, 5. All right. So now the queue length will be 3, 10, 5. So till this point, we are going to know, okay, last element is 3. We are going to put 3. But at this point, we are going to know last element is 5, because till now we have not removed the 3. Right. So for the 3 as well, we have to put the left child and the right child. So we have to do is like, anyhow, this is becoming confusing. So I'll let me delete this. Anyhow, this is unnecessary, get confused. One second, just a second. Okay, we have store one. We have, so this logic is clear, right? So this logic is clear. What we are doing is we are taking a queue. We store the first element. Then we pop it. Then we store its left child. Then we store its right child, which is fine. And as soon as we pop it, we are storing it to the resultant array. We are storing, so for the first, it is perfectly fine. But here our code becomes wrong, because if we pop and we are storing it to resultant array, then we have to store the two. So it means we can't store. So here we have to put some condition before storing. Before storing, we have to put some condition whether that is the last element or not. And this is the queue. So how we are going to know whether this is the last element or not? By the size. So let's calculate the size. So this is basically level size. So till this level, its size is 1. For the level 2, size is 2. So what we can do is, before popping, so we can do level size is equal to length of queue. Length of queue. All right. And now we have to run a for loop. For loop. So because we have to run a for loop. So for I in range of level size. So we are running a for loop. So we are running a for loop. Now we remove the element. We remove the element. Now this is creating the issue, right? So this is, so here we need to put some if condition. So what is the if condition? So we are running a for loop. So if, because we are running a for loop by considering I. So we need to check whether I, because first element is here 1. We put in the queue, we put initially 1. So we calculate the level size. So level size is equal to 1. Okay. Now we need to run a loop one time. So we are running a loop one time. As soon as we know whether I reaches to level size, then it means this is our last element. So if I equal to level size minus 1, it means this is our last element. Then we have to insert. So here, so in the first case, so we are running a loop till 1. So I is 0. I is 0. Is 0 is equal to level size minus 1? Yes, because 0 is equal to 1 minus uh, level size minus, yeah, 1 minus 1, 0. So 0 is equal to 0. So it means this is our last element. So we have inserted. Now, so now we have inserted. So that's why we have stored. Now we have inserted 2 and 3. So we inserted 2 and 3. So now we again check the level side. Okay, what is the level side? Because the for loop has been finished for the first thing. Now we have again checked the level side. Okay, what is the level size? Level size is equal to 2. So now we need to run the loop 2 times. All right. So I, I initially I is equal to 0 and 1. So it is 0. So we are earlier, what we are doing is, if we have not put in this condition, what we are doing is we are directly appending 2. But we now put the condition. Is I is equal to level size. Level size is 2. Now I is equal to 0. So 2 minus 1, 1. 0 is not equal to 1. So this is going to be like fail. Not fail, but so this is going to be skip. Now we remove the 2, because we already popped 2. We already popped 2. And so we have only 3 left. Now we have to like insert the, is there any left child of the 2? No. So this is also going to be skipped. Is there any right child of the 2? Yes, there is a right child. So we have 5. We have 5. So we have inserted, but level size we already calculated. Level size we already calculated. We are running again loop. Okay, so now I is equal to 1. I is equal to 1. So we have pop 3. So we have pop 3. We already pop 3. So now 1 is equal to level size minus 1. 2 minus 1. Yes. So it means this is the last element of the earlier level. So we have inserted that value, and then we put the left child of 3. So there is no left child. Is there a right child of 3? Yes, there is a right child. So we have put 4 here, and 3 has been popped. So 5 and 4. Again, we are calculating the level size, because the for loop has been finished. Again, we are calculating the level size. So level size is equal to size is equal to. So now it means we need to run 2 times this loop to get the last element. Because why it is like mandatory? Because if we remove 4, 5, we have to insert its left child and right child, and 4 is still there. So we will not able to understand what is the left child or what is the last element. So we have to design the logic in such a way. So if you focus, if you just ignore this line and if you just ignore this for loop, the rest of the logic will be normal. Like we are popping element, we are storing all the, because how you are going to store all the elements level by level? Only this way, na? Pop first element, store left child, right child, then pop second element, store left child, right child, right? But if we are popping, right? So we have to check whether that element is the last element or not. All right. So how we are going to check for the particular level? By running some code, because this level could be a 4 element. This the next level could be of 8 elements. The next level could have the 16 elements. So we have to pop each and every element to insert their further left child and right child. So that's why we need a for loop for that particular level. And to get that level, we have to first calculate the level size, and then whether that is the last element or not, we will put here. So let's try to run this. So run it. Our sample case has been accepted, so let's try to submit. So our solution has been accepted. All right. So that's it. That's the end of the video. Don't get confused by, you see, like what is the if condition. If condition, I already explained why we put the if condition, because if we have not put the if condition and we just put this out, then we are, whatever the element we are popping, we are inserting everything. All right, so that is not what we want. It means we are creating from all the elements we are creating a list, but that is we don't want. That is normally tree traversal. We have to do the tree traversal, but whatever the element we are going to print or whatever the element we are going to store, we have to put some logic. And what is that logic? This is the only logic. Okay, whether that is the last element or not. And we know we are storing in some list, and we are popping all the elements. So how we are going to check whether that is the last element or not? Just calculate the size of the, because we are running a loop. So just calculate the size, whether the I reaches till endpoint or not. Just I reaches till endpoint or not. So if I reaches till endpoint, only then we are going to insert. So we need the size of that level. So to calculate the size, we need this, and we need to loop till that point before calculating the next level. Because once that all the elements get popped, all right, then the next level will be calculated. Only then the next level size will be calculated. Otherwise, if you put level size inside the for loop, then it will be messy. Because once all the elements get popped for the earlier level, then and then for the next level, all the elements get inserted, then only we are going to calculate the level size. That's why the level size is calculated outside the for loop. So that's it. That's the end of the video. You can also try this question. Thank you. Thank you very much.